myself Sonigra, and today in the subject of mechanical drafting we will discuss about intersection and penetration of solids and surfaces. As we know, there are four types of basic solids, that is prism, pyramid, cylinder and cone. And in today's discussion we will cover two solids, mainly intersections of two prisms and intersections of two cylinders. We will also cover the objectives mentioned here, that is to understand the concept of intersection and penetration of solids and surfaces, to solve the examples based on intersection of prism to prism, and to solve the examples based on intersection of cylinder to cylinder. So these are the objectives of today's presentation. Now, what do you mean by intersection, or what is intersection? When the surface of one solid meets that of another, the line or lines along which two surfaces meet each other is known as the curve or line of intersection of the surfaces of two solids. For example, two prism or two cylinder meets each other, and the surface where two surfaces meet each other, that shape formed by that intersection is called as the intersection or intersection of surfaces of two solids. This is one example of intersectional curves of two cylinders. You can see here one red colored cylinder is in a standing position and another yellow colored cylinder is penetrating to this vertical cylinder, and the curve of intersection is shown over here. These two curves are called as the curves of intersection. Similarly, if a hole is cut in a solid, the line along which the surface of the hole meets that of the solid is known as the curves of intersection. Means if instead of two solids only one solid is there, say for example square prism or cylinder, and if any hole is drilled in that solid, then also some curvature shape would be there, that is cutting portion. So that is also covered in this intersection and penetration of solid. Of course it is not penetration or intersection, but even we consider it as a intersection of two cylinders. Now, determination of curve of intersection. There are two methods to determine the curve of intersection that we will discuss today. And the first method, that is line method, or it is also called as generator method. And second method, that is cutting plane method or circle method. In the first method, that is line method, we find out the points over the surface or periphery of the solid, and then we find out the final point. And in cutting plane method, we assume that the solid is cut at given angle, or the one solid is cut by another solid, and we assume that there are number of cutting planes, and because of the formation of those cutting planes, whatever shape is there, that we find, that is the second method. In the first method, that is line method, in this method a convenient number of lines are drawn on the surface of each solid. When these lines of the two solids intersect, they must intersect at a points that are on the curve of intersection. In this, a number of lines known as generators are drawn on the lateral surface of one of the solids. For example, one solid is a cylinder, then cylinder is not having any edges, so we draw imaginary lines over the periphery of the cylinder. We divide the circle into equal number of parts, we find out the imaginary generator, and from those generators we draw lateral surface and then we can interpret the points. The points are marked on the surface of the other solid where these generators intersect. These points are then joined in sequence to get the line of intersection. That is the first method. In the second method, that is called as the cutting plane or circle method, two intersecting solids are assumed to be cut by a number of section planes. The cutting planes may be perpendicular or parallel or inclined to either or both the reference planes HP and VP. Points are marked on the surfaces of the solids where these planes cut, and these points are then joined in proper sequence to obtain the line of intersection of the solids or the curve of intersection. And this method is also used, but we should use only single method to have better understanding of the concept. So we will use the first method, that is line method or generator method, to solve the problems. These are the solids, as we know, that we will cover in today's presentation, that is square prism and a cylinder. And the square prism is specified by two parameters, that is the side length and its height. Similarly, the cylinder is also specified by two parameters, that is diameter and its height. This is one example of intersection of two cylinders, that is both the diameters are different and one cylinder is penetrated by another cylinder. We also will discuss this kind of problem, the intersection of two square prisms, intersection of cylinder and prism, and intersection of two prisms which are inclined at some angle with HP and VP, and the edges are also not parallel to any plane. So this is the outline of today's problems. Now first problem, example number 1. The data is given like this: a square prism, 50 mm sides and 100 mm height, resting on its square base on horizontal plane, such that two sides are parallel to vertical plane. It is penetrated by another square prism, 45 mm sides, having axes parallel to both the planes. All the faces of penetrating prism are equally inclined to HP and vertical plane. Draw front view, top view and side view showing the lines of intersection. Here square prism is given, which is resting on its square base on HP, such that two sides are parallel to vertical plane. It means that its top view would be a square which will be drawn below XY line as we use the first angle projection method. So in the first step we draw a square having side length 50 mm below XY line in such a way that two sides are parallel to XY line, which is given in the first line. Now after that, in the second line it is given that this square prism is penetrated by another square prism having side length 45 mm and axes are parallel to both the planes. So whenever it is given that the axis of any solid is parallel to HP and VP, means both the plane, in that case we have to draw its side view first. In side view it should be drawn in such a way that all the sides makes an equal angle with XY line, that is 45 degree in case of a square. So let me draw this problem. First we draw its top view as it is drawn over here. Its top view is a square having side length which is given as 50 mm. So first we draw this square as drawn over here, square having side length 50 mm, and its front view. To draw its front view, let me take projection from its top view. So for that we transfer these points to here like this, and in front view this square prism will appear as rectangle as is shown over here. The height is not given, height is given as 100 mm. So at a distance of 100 mm mark a point. So this is a square. You can name the endpoints, say A, B, C and D, and as it's a top view, dash marks are not there, and this is a front view, so we can mention A dash, B dash, C dash and D dash respectively. So this is the front view of this square prism. Similarly we can draw its side view by drawing this meter line. Meter line is drawn at an angle of 45 degree with XY line like this. This angle is 45 degree, that we know, and after drawing the horizontal line from A, B, C and D to this meter line, transfer the points over here. It will cut the meter line at this point and at this point. From these 2 points, draw straight vertical lines like this and this. Now after that, suppose A point is here, horizontal line from point A is here, A is here. So horizontal line from point A dash, both will intersect at this point. Name that point as A1. Similarly, B point is here, so line from point B is this one, line from point B dash is this one, so point B1 would be here. Similarly, point C1 and D1 would appear like this. Now we have to draw the position of penetrating solid. So penetrating solid is also a square prism having side length 45 mm. So we need to find out the axis of this solid, and as we know, axis is at the middle or here. So draw the axis by drawing center line like this, having a one long dash and one small dash, that we know. Then after, find out the midpoint of this axis. Total height is 100 mm. So here at a distance of 50 mm, the axis would be there somewhere here, and from that axis draw a horizontal line like this. It shows the axis of this square prism. Now we have to draw a square over here, making this point as a center in such a way that its all sides make equal angle with XY line. That is, that angle is 45 degree. So let me draw that 45 degree line from this point like this, and side length is 45 mm. So how to draw this 45 mm line? So for that there are number of methods. You can use the angle measuring device, or this distance is 45 mm from this to this. This distance is 45, so this would be 45 square by 2, and by using Pythagoras law we can find out this side length, because suppose this is x, this is x, so x square plus x square, that is 2x square is equal to 45, and from that we can find out value of x and that distance is this distance, and from that we can draw this front view of this square prism. After that, let me draw its side view. So for side view, from this point transfer the points over here, and as this solid, this square prism is penetrating through this solid, so for that here the penetration would be there. So that is shown over here. You can see here in this view, these are the two solids, one square prism and another is a penetrating prism, and we have to draw three views of this assembly. Of course it's an assembly, it's an isometric view of two intersections. So this is the front view which we have drawn, this is the side view. If we look from the side to this solid, it would appear like this. Similarly, if we look from the top side, it would appear like this. So there are two solids, shown by red colored is a square prism, and shown by this white color is another square prism which is resting on HP such that two sides are parallel to XY line. So this square we have drawn, this front view and this side view we have drawn. Now we think about this shape, how to find out these points, that we will discuss here. Now to find out these points of intersection, let me transfer all these points from here. The length of this solid is given to us, so according to the given length, and that is 100 millimeter. So 100 millimeter is the height, or we can length is not given, so any convenient length could be taken as a reference. So this is the side view of this solid, and here this solid, this edge is inside this vertical prism, so it will not be visible, hence that edge is to be represented by the dotted line like this. This dotted line represents the hidden edge. Similarly, here also dotted line will be there, which represents the hidden edge of the penetrating solid. Here these edges are outside the solid, so if you look from this side, from here, if you look from here, this edge would be visible. So this edge would be fully visible, so which should be drawn with the full line from one end to another end. So this is drawn. Now we think about this point. These are the points 1, 2, 3 and 4 are the points of intersection. So from all these 4 points, let me take projections. So for that, from these 2 points draw a straight horizontal line, and this horizontal line will pass through the same points, and it will appear like this from here, from this end to this end only. Full line would be there. Similarly here also full line would be there. This is, so this we have drawn, and this height would coincide with this. After that lines will not be there. So this is the front view, side view of given assembly. Similarly we can draw top view of this square prism by taking projections from here, from this corner take a projection like this, and it's an outside line, so no dotted line would be there, that would be full lines like this. Similarly by drawing vertical line from here up to meter line, and by taking projection we can draw its top view as well. So this is the top view. Now in top view this corner is remain, so that corner line would appear here as a full line in the outside, and in the inside of this square prism that edge would not be visible, hence it is represented by the dotted line as shown over here. So you can see here, this is the problem. Here colored line shows differentiation or different solids. We have drawn this square. First we have drawn this green colored square having and this side length of this square is 50 millimeter. So you should insert the dimension like this. SQ 50 means it's a square of 50 mm sides. After that we have drawn this square having side length 45 millimeter. So here it should be written like this, SQ 45. It means it's a square having side length 45 millimeter. Length is not given in this data, so we have assumed 70 millimeter as a length, so that should be written over here 70 millimeter. Similarly this height is given as 100 millimeter, so that should be written over here, that is 100 millimeter. And to insert the dimensions, one unique dimensioning method should be employed. Here we have used aligned method of dimensioning. Here restore lines should be either erased or drawn much lighter. Even this meter line also can be made much lighter. Only this square